Hi, I'm Paul. We're doing Leetcode must-know interview questions. Today's challenge is same tree. Same tree. Rated easy. The challenge is, given the roots of two binary trees, P and Q, write a function to check if they are the same or not. Two binary trees are considered the same if they are structurally identical and the nodes have the same value. For example, this example 1, same tree. It's structurally identical and the nodes have the same value. Example 2, false. The trees are not structurally identical. One node has a left subtree, one node has a right subtree. Example 3, also false. They're structurally identical, but the nodes don't have the same values. Okay, anything else here? Constraints. The number of nodes in both trees is in the range 0 to 100. Okay, that's actually important to know. The 0 part of it is anyway. So let's scoot this over so we can see the method signature. Actually, before I scoot it over, let me talk about what we're going to do here. So this example. Example 1, is it the set? Are these the same tree? Well, we don't know just from getting pointers to the head node, but we can tell if the head nodes are identical, which they are. It's 1 and 1. Now, binary trees are recursive structures, and it's a good idea, if you have a question about trees, to start out thinking, could I solve this recursively? Because often the answer is yes, not always. In this case, well, we can tell whether the root nodes are identical. To be identical, they just have to exist and have the same value. And then we can do recursive calls on are the left subtrees identical and are the right subtrees identical? And keep doing that, and we'll process it one node at a time, and we'll be able to return true or false. So recursive solution. Let's start out with this. It's possible that these one or both of these tree nodes that we're getting as input is null. That would indicate that 0 nodes. So if P equals null and Q equals null, it doesn't say this specifically, but it doesn't make sense to return anything except true in that case. Let's copy that line. Okay, so we'll copy that, and probably we should fix the ifs here. All right, let's change this. Or, all right, if we get past that first, well, the first if statement says, if both trees are empty, return true. All right, identical structure, no values. If we get past that, we know that at least one of the trees is not empty. So the if P equals null or Q equals null says one of the trees is empty, but the other one isn't. And in that case, we're going to have to return false. All right. You know what? I don't really want to copy that. Let's do this. I forgot what is the value field called? Val. Okay. Val left and right. If we get this far, we know that both trees are not empty. So we can say if p-val equals q-val. And if that's true, what we're going to return is a Boolean expression, and that is, actually, that doesn't have to be in parentheses, is same tree p dot left, q dot left. Are the left subtrees identical? I'll put this on the next line. Are the left subtrees identical? And are the right subtrees identical? And okay, you know, I think that did, but I think the Java is going to complain if we don't put a return statement here. It's going to say that not all paths return a value, which would be true. It's just that there's really no way to get out of that if statement without returning something. Okay, so return false, but really that's just there. We shouldn't ever hit that. So let's try running it. All right, worked fine. Move this over. Submit. And what do we have? There are not enough accepted submissions to show data. It's kind of surprising. Okay. In any case, you know, this runs very quickly, and that's it. Key takeaway again: if you have a question about trees, think first of all, can I do this recursively? In this case, the answer is yes, and you know it does become a pretty easy problem. So that's it. Feel free to like, subscribe, comment, and see you next time.